Hello and welcome to today's problem 567 permutation in string. So you give two strings s1 and s2 and you want to return true if s2 contains a permutation of s1 or false otherwise. So in other words, return true if one of s1's permutation is a substring of s2. For our first example, we have s1 and s2 over here. We return true because in s2 we have a permutation which is ba over here. For the second example, we return false because AB or BA is nowhere to be seen, and those are the two possible substrings of string 1. Okay, that makes sense. So let's think more about what the condition is in order for us to be able to return true. So we want our condition for a substring to be valid is if it's a substring of s2 and like a permutation of s1, right? So of s2 permutation of s1. Given this condition, we can figure out Okay, so one thing we know for sure is that we have to iterate through string 2 in some way, taking a look to see whether or not the count of the characters within string 2 will ever be equal to the count of the characters in string 1. Okay, so an idea I have actually is, let's say we have like this example over here. So we have the string. What we can do is we can have a left pointer here and then a right pointer, and we can start off the right pointer and have it the length and have it be the length of s1. So we'll have it, let's say like because the scenario for this one is AB, we want this one to be AB as well. Right. Yeah, right. Okay. So we have AB over here. And since this is of length 2, you want to create two pointers spaced apart at the length of the s1. So since this is 2, this is going to be 2 part. You want this to be at E and I. So this is where you want these 2 pointers to be. From here, what you can do is you can compare the counts of these 2 values and see whether and determine whether or not the count of those 2 values are equal to the count of the values in string 1. So in order for us to be able to do this, we're going to have 2 hash maps, right? So string 1 hash map over here, which basically contains the count of all characters in string 1, and then string 2 hash map, which contains the count of all cars in s2. So now that we have these 2 hash maps, what we can do effectively is figure out whether or not a substring is valid by comparing the values of these 2 hash maps in order to see whether or not they're equal to each other. And if they are, what we can do is return that final value. So, okay, let's put this into writing. So what we can do is create 2 hash maps with count of all cars in S1 first. Next thing we're going to want to do is we want to figure out what the counts of the characters in string 2 is, right? And actually, I don't think we need to have all the characters in S2. We just need to have 2 pointers, right? 2 pointers. Length of S1 apart. And then from here, what we have to do is figure out what the count of these are. So from this, figure out count of elements in window. After you create these 2 pointers, as like the length of string 1 apart, and you forget the number of elements in the window, and you count those elements together, you can effectively check whether the count of cars in window is equal in S2's window is equal to that of S1, and then if true, if that's valid, then we add 1 or return true. Otherwise, what we're going to want to do is return false. So return basically, or like keep checking. So move left pointer forward, move from count. Yeah, and then same thing with the right. Move left and right pointer forward, removing them from a count and adding the right pointer's value to the count. Right. Okay, so just to walk this through again with our example. So we have two hash maps with the count of all characters in S1, and we have 2 pointers, the length of S1 apart. You want to figure out how many elements are in the window, and in order to do that, we want to check the count of the characters. Basically, for this one, we have like a hash map. Well, like the string for string 1, this will be A is equal to 1 because that's the count, and then B is equal to 1 as well. So we start off with those ones, and then from there, this will be empty initially. We'll move the right pointer forward, basically, or figure out a way in order to count the values of like count the characters within that sliding window. So it equals E to 1 and I is equal to, yeah, and where I is equal to the to 1 as well. Okay, so actually, yeah, so one way we could do this is by just moving the right pointer forward and basically adding the values as you traverse along. Another way to skip this is by using the counter object in Python to basically initialize this hash map. Initialize a hash map of like up till like length of string 1 before traversing through it like regular. So I'll show you a little bit more that means through code, but I'll put a note for that for now. So we'll have create 2 hash maps of count of all characters in string 1 and up to len S1 characters for S2. So yeah, okay. So from here, yeah, figure out count of numbers, elements in window, etc., etc. Okay, so anyways, back to what I was saying. We basically have these 2 hash maps, so S1 and S2 over here, where you have the count of all the characters in S2, and then you can effectively check to see whether or not these 2 hash maps are equal to each other. These values are equal to each other. If they're not, then we don't accumulate the result. We'll have like a result variable here. We don't return true actually, because that's what our output should be. We don't return true. So then we check again by moving this right pointer forward, deleting moving the left pointer forward and deleting the element that we just removed and adding the element that was just added. So in this case, E becomes 0 and D, we add a D value to equal 1. So basically, at every single given iteration, we're going to have to check to see whether or not the count of the values are equal, and we can do that by basically iterating through everything in string 1 and seeing whether or not the values are equal in that situation. Right. Okay. Right. So another interesting thing about this is when we subtract it to 0, we want to, yeah, right, okay. We want to remove the character, right? Okay, yeah, this should work. Sorry, I'm thinking about it. It should be fine to leave the E equaling 0 because like basically what we're going to do is we're going to traverse through the string 1 hash map, check to see whether or not A exists in the second one, and like whether or not its count is the same thing as B. And because it's just in the sliding window, the element of the sliding windows, it'll only be counting the things there and it'll have the current elements in there. yeah, it should be fine. This shouldn't matter. So anyways, well, we keep traversing through the array, adding back and forth, and removing until you encounter this one. At this point, what should be the case for this hash map is that I is equal to 0, E is equal to 0, D should be equal to 0, and B should be equal to 1. A should be equal to 1 as well. So at this scenario, we can go ahead and traverse through the string 1's hash map, check to see A, yep, it's here, it's equal, same thing as B, yep. At this point, you're going to want to return true. So we'll go ahead and do that. And for situations like this one, where it's A, E, I, D, B, O, A, O, O, as you traverse through it, eventually you'll come across the end of the basically the string, and at that point, if the length of the right pointer exceeds the length of the string 2, so let's say like this is 1, 2, 3, 4, 5, 6, 7, 8 characters. So if the index, because it's 0 indexed, if 7 is greater than the length of string 2, greater or equal to the length of string 2 minus 1, then that's when we're going to do it. So this will be 7 greater or equal to 7. That's when we're going to want to stop the while loop over here. Or yeah, if it's greater. Okay, so I'll go ahead and begin coding up the implementation of it now. So first, we're going to have the string 1 hash map, which is equal to, basically, we can use the counter object like we were talking about before to count all the elements in string 1. So we'll go ahead and do an import at the very top from collections import counter. This will save us some time for having to loop through the like every single element in string 1 and adding it to a hash map manually. And yeah, so we'll go ahead and do that. We'll create a counter, and we're going to put initialize it with the values from string 1 over here. Next thing we're going to want to do, have another hash map. So s2 h hash map is equal to a counter of string okay, so we'll just have a counter hash map here, and then from here what we want to do is we want to iterate and add the elements up until the length of s1. So we'll have the left and the right pointer like we were talking about before over here. So we have left is equal to 0, right is, oh actually we'll use the right pointer to iterate through the array. So we'll go ahead and do for right pointer in range length of the string 2, what we're going to want to do, so what we're going to want to do is pretty much, or actually length of s1 first. What we're going to want to do is iterate through and add that to the string 2 hash map. So we'll go ahead and do that. So we'll do basically counter, so s2 hash map equals s2 hash map dot get. We're gonna get to check to see whether the value exists, initialize it with 0, and then we'll go ahead and so hash map dot get the value of s2. Wait, let me think about this. So what we're getting is getting the hash map at s2, and we're checking to see whether or not the key for s1 r exists. So so for the range, for the right pointer in range length s1, we want to get the value at s1. So we'll just do s1 at the right pointer. We'll check to see whether or not that's been initialized, and if not, we add 0. We have it set to 0. If it is, we set it to 1. Well, like we increment it by 1. So at the very end of this, what should happen is we should have the hash map looking like initialized with E and I over here. So you have the E, you have the right pointer over here at the very end. The left pointer stays the same, and at this point it adds E and I. So E is equal to 1 and I is equal to 1 over here. And so this is where we are currently. So once I well, yeah, once your values are set to basically, yeah, once your values are set to that over there, what we're going to want to do next is check to see basically whether or not the elements are equal to each other, and then return true if that's the case. If not, then we're going to want to keep traversing forward. So yeah, right. So we'll actually do that right now. So for r in range length s2 this time, since the right. Yeah, so okay, so since we've already iterated first through the first few elements. Okay. Since we've already iterated through the first few elements, we have e and I equal to 1 over here. We want to do a check to see whether or not that exists. So we want to say for v, for every single value, or for a key value in s1 hashmap.items, you're going to want to check to see whether or not s1 hashmap at a given key. Yeah, you're gonna want to see whether or not the value, if value is equal to s2 hashmap at the given key, then well, if that isn't the case, then you wanna return false. Otherwise, you want to keep going, and at the very end, you want to return true over here. Yeah, so okay. For basically this checks whether value of hashmap of s1 of strings 1 hashmap is equal to that of strings 2 hashmap. So value, and then if it's not, then we return false. Otherwise, we keep going to the very end and we return true. Now, basically, we want this to occur as we keep sliding through the window, right? So this is like steps, basically steps 3 and 4. So as this is happening, we want to do another for loop. We'll do a for loop before actually. For every single okay, let's see. For r, right, okay, actually let's have the right pointer start. We can set that to equal 0 over here, and then for every single okay, actually, another way we could do this instead, to make this a little bit simpler, is to have a... Okay, actually, yeah. We can have the counter for S2. It's empty. We traverse through, basically, while r is less than the length of the string 1. Basically, string 1 minus 1 because it's 0 indexed. Yeah, because it's 0 indexed, this is what we want to do. We want to add that to the strings 2 hash map, increment 1 at the very end of this, while r is less than the length of s2 minus 1. That's the next thing we want to do. While it's less than the length of s2 minus 1, we want to go ahead and do a check to see whether or not the values in the hash map are equal yet. And then while we're doing this, what we want to do is we're going to want to traverse forward if this isn't the case. So to traverse forward, we have to remove the elements at the left, like at the like the left pointer, and then add the element at the right pointer. So okay. Right, okay. Okay, so from here, what we can do is have an if statement. Well, actually, okay, so we'll just work on moving the left pointer forward. So we'll do left and the right equals L plus 1, R plus 1. So we'll move the left and the right pointer forward. And before we do this, what we're going to want to do is at the left pointer, we want to remove that from the hash map. So s2 hash map dot remove, or like s2 hash map at L, or at the character of s2 at the left pointer. We'll for that one, we're going to want to subtract that by 1, so minus equal 1. And then, yeah, right, from there, we also want to do the same thing with the right one. So s2 at the right pointer, we want to add that by 1 before traversing it forward, until eventually R reaches the very end. And then we keep checking over here over and over and over again until we like we notice that all of them are equal to each other, all the elements in the hash map. Okay. So, another thing I'm thinking about in terms of optimization is whether or not it's a good idea to constantly be looping through the like all the elements in the S1 hash map in order to check to see whether or not those values are the same. Let me think and see if there's any other ways that we could optimize this with. Okay, well, what we could do instead is we could populate the both hash maps with okay. So in order to stop the values from having to iterate forward, like iterate multiple times for on the first hash map, okay, actually, let's go ahead and just make sure the solution works before having some more thought about like whether or not we can optimize that. So, okay, let's just run through this example again from start to beginning, see where we're at. We start off, A1 is equal to 1. Yeah, A is equal to 1, B is equal to 1 for the first hash map. For the second one, we start off with nothing, and then what this while loop does is it traverses through up until length of S1 minus 1. So we start off here, left pointer is equal to 0, right is equal to, basically it moves forward to what the length of it is, which is 1, because it's length of S1 minus 1, moves it up by 1, and it checks and adds, basically adds the, increments the items for the second hash map so that the second hash map ends up looking like this. I is equal to 1, E is equal to 1. And then from here on, we can go ahead and do a check to see whether or not for every single key and value in the hash map's items, whether or not this case is occurring. If the, what is it? Yeah, so if not, then you want to basically continue, or okay. So if there is a case where they're not equal to each other, the value for one of the hash maps isn't equal to the key for the second hash map over here, you want to just keep continuing on for the while loop. Otherwise, if you manage to get through all of them and it's all valid, then you can then return true pretty much for it. So yeah, that makes sense. Actually, a situation where there might be an error with this is if you have, we don't know. Okay, wait, no, never mind. What I was going to say is that there might be an issue with there being like extra characters in the second hash map, string 2's hash map, which may cause the while loop to return true even when there's extra characters which shouldn't be there in the second one. But because the window is of size k, we specify this, well, it's not size k, size length of string 1 in the beginning, there would never be a case in which that would happen. So this would keep working. Yeah. So, okay, we keep iterating through again for kv and value in each one items, check to see whether or not they're equal to each other, otherwise keep continuing. Yeah, and then return true at the very end. If it isn't, then what we do is we basically decrement the from the sliding window the element that you're currently at the pointer that you're currently on is on, and then add the right one, keep on moving to the end, and at the end return true. At the end return false, actually, but you want to return false if none of those values match. So let's go ahead and run this. Int object. Oh, right. So because the counter object in Python actually, like, it uses the default, like, the implementation of the hash map in Python, but it also includes a default initialization value, which basically like makes it so that you don't have to initialize the value manually as you go about it, if I remember correctly. Oh, sorry. S2 hash map at the string 2 at R. Yeah. So at the string, at the second strings, right, at the second string's character, at the right pointer, we want to increment that by 1 and put that into the hash map. So we'll go ahead and run this again. Looks like the time limit exceeded, so there's something wrong with my implementation here. Oh, we forgot to increment the right pointer forward by 1 every single time for the initial one, for the initial while iteration. Okay. So for this one, we're returning true even when it's supposed to be false. Why is that? Let's have a look. Okay. So if we take a look at string 2 at the left pointer, so for this one, okay, let's say like for these values over here, right? String 2's left one. Okay, if we start off with here, string 2's left one will be I. So I is subtracted from the hash map, and then where this is currently at, E, it's added by 1. Let's think about whether or not it should look like this. It should be the same regardless. Okay. Let's do some debugging over here. At every single iteration of the while loop, let's go ahead and print out what hash map string 1 hash map is and string 2 hash map is. Okay. So at the beginning, just like we expected, A1 is equal to 1, B is equal to 1, and E is equal to 1, and at the end, same thing, I is equal to 1, and E is equal to 0. Wait a minute. This counter should also include I, because that's what you want to start off with at the beginning. So if we run this again, take a look. Okay, so it starts up with equals 1, I equals 1. And then what it does next is for the second one, same thing. This one, I is equal to 1, D is equal to 1, E is equal to 0. We decrement it like it should be. So now it's at I. Oh, wait a minute. Okay, so this is interesting. So for the second one, second iteration, you have I equal to 1, D equal to 1. Yeah, oh yeah, the I D equal to 1 equal to 0. Yeah, that's right, that's right. So I and D over here, that's what it is. And A, B is equal to 1. And then for the third one, you have D is equal to 1, B is equal to 1, and then E is equal to 0, I is equal to 0. We keep on moving on, so on and so forth. And it should be up to the length of string 2. Right. Oh, I see. If those values aren't even there in the first place, it'll still return true regardless. So, like, because like you're looking for A and A is not in there, it's still valid because they're not equal to each other. Then you continue. Then you return true. So this actually, we need to modify this logic. If V equals this one, yeah, then you want to keep going. If not, yeah, right. So if basically if this is equal, want to keep going, want to keep checking for all of them, and then okay, so you can check if V is equal to S2 hash map at K. Then you can keep continuing up until you reach the very end. So we'll have maybe we'll have an accumulator here. So we'll have like length or like we'll just have an accumulator. So we start off at 0, and then we basically if they're equal to each other, accumulator plus equals 1. And then if at some point accumulator is greater or equal to the length of the string of string 1. Yeah, so if the accumulator is equal to greater or equal to the length of the string 1, then what you're going to want to do is return true then. Otherwise, you just want to keep basically you want to just keep going and continuing. Okay, that makes sense. Go ahead and run this now. Great, it's accepted. Should for these two test cases, we'll go ahead and run this to check what it's like for the other test cases as well. Oh, okay. So this one, we have false when you expect true. Let's have a look. Okay, let's run through this example over here. You have pretty much A starting at, so S1 starts off with A. Okay, let's actually, yeah, okay. So we use this as a test case, and we'll go ahead and run this. Or okay. Okay. Okay, so basically, okay, let's just run through this. We have A, which is equal to okay, so we have the string 1 hash map okay, so S1 is equal to A, S2 is equal to AB. Basically, you want these two ones to be set up so A is equal to 1, and there's no B. For the second one, we start off empty, and both pointers at the beginning, we traverse forward by 1. So string 2, while it's less than the length, then you keep moving forward. Well, you move this because it's because it's a 0. Oh, I think this actually has to be equal. Well, sorry. This has to be equal to the length of it because you need to include the I as you're going through it as well. Oh, actually. Okay. Run this again. Interesting. Let's have a look here. Okay, so start off with AB, and you have, if we go ahead and take a look at the test case 3, we have AB as part of string 2 over here. So we have string 1 equal to A, string 2 is equal to AB. You pretty much iterate through. Well, it won't do anything at all. So because it starts off at the length of string 1 is 1. So while it's less than, you just increment it by 1. So this will end up being this. A equals 1 over here. Because you're at AB. And that should return true. But what's happening is you're checking to see whether or not the element in the hash map is equal to whether or not all elements in the first hash map is equal to the one in S2. So I have here a Go ahead and run this. No. Okay, let's have a look. We have string 1 equal to A, string 2 equal to AB. First, you okay, let's print out the results of the hash maps after you complete this initial statement. Go ahead and submit this first. Okay. So these two counters are equal to each other. A is equal to 1 and B is equal to 1. And then from here, while R is less than the length of S2 minus 1, this is where it trips up. Because it's not even running this while loop in the first place. So this would actually be while the R is less than the length of S2. Okay, let's solve that issue. But now we're coming across another one where ADC, DCDA, the output is false and you expect true. A is equal to 1, D is equal to 1, C equals to 1. ADC, and then DC, D is equal to 2, and C is equal to 1. That makes sense. You start off here. And then for the second one, CDA, it only checks D and C. It doesn't include A. Weird, it doesn't traverse forward. But if we run this, oh right. Huh. It has to do with this one. We have D is equal to 2, right? C is equal to 1, but it's not including that last value because it's not incrementing that last value. Because that last case isn't running. So in order to check that last case, we have to do like this one. And then from here we only want to increment, we only want to do this check if length like if R is less than the length of S2. We only want to increment forward if it's less than S2, otherwise we want to keep it the same. Okay. Oh, we also have to watch out for an edge case where string 1 is greater than string 2. So if string 1 is greater than if string 1 length of string 1 is greater than length of string 2, we want to return false automatically because there's no way that would work. I realize it's not actually a constraint for S2 to be greater than S1. So that's something we actually have to watch out for. Okay. Next thing we're gonna have to look out for. ABCDX, ABCDE. ABC, D. Interesting. So this one we want to turn false. It's supposed to return true. A2 is the same, B2 is the same, C2, D2. E is 1 and X is 1, yet it's not returning true. Because the counts So these values are the same. Hmm. Actually, another thing I was thinking about, in order to prevent a whole ton of like unnecessary zeros from being added to the hash map, we could just remove that value entirely. So we could do like an if statement here, like if s2 hash map at the very end of these things, if s2 hash map at s2l is equal to 0, what we can do is then just remove that from the hash map altogether. So s2 hash map s2l dot remove. Yeah, we can just remove s2. Yeah, we can just do remove s2l, and then from here what we can do is we can then go ahead and we don't need to actually traverse through. We can let Python do that for us by just checking to see whether or not the values are equal to each other. If s1's hash map dot items is equal to s2 hash map dot items, then we return true, otherwise we return false. Go ahead and submit this. There might be some syntactical errors here. Right, so s2 hash map. We do a quick search. We can use the dot clear. So we'll move that place in the memory. Actually, do a quick look again. You have to do delete. Oh, man, what's going on here today? Go ahead and delete the elements where it's equal to 0. Nice, it's accepted. Okay, yeah. Right. Right, so the reason why it's accepted is there was an issue with it before, having to traverse through, and basically like it's kind of an overcomplication to use an accumulator and like running through every single like elements manually in order to basically like check to see like whether or not like those values are equal to each other. What I did instead over here was have a like do the same thing as before, except this time when the value when the element here is equal to 0 again, like when you move the left pointer forward and it's equal to 0, I can go ahead and remove it from the hash map entirely. So this way we can perform this operation, and we're actually like saving space in the memory like itself by not having to have like the letters and like all that as we keep going on forward. Yeah, I'm actually quite curious. I want to take a look at the solutions board and see whether or not there's a better way of doing this. Interesting. So yeah, so that's what we did here. We created a hash map with the count of every character. And we decreased the counter for characters that occur in the window. Yeah. As soon as all counters in the hash map get to 0, oh, this is actually kind of interesting. So we slide a window over the string s2, and decrease the counter for characters that have occurred in the window. Interesting. So as soon as all counters in the hash map get to 0, that means you've encountered the permutation. If all encounter I equals 0 for I encounter, you return true. Otherwise, you return false. That's an interesting way. So this way you don't have to have two things and compare the values for that one as well. Huh. Right. Then we have this one, optimized solution. Okay. That's actually quite interesting. I might have to look into that as a possible solution in the future. But yeah. Well, thank you guys for watching so much of this video. This is my attempt at the problem and my eventual solution. For the future, what I'm going to work on is making sure I think I tripped up a lot by not having my steps for the problem fully fleshed out before I began going through the problem. In the future, what I'm going to do is make sure this is fully set and I have a concrete idea in my head before I begin implementing. Second thing, more on the actual implementation itself. Yeah, this was a smart way of doing it. I shouldn't I was thinking when I had the while loop and the accumulator and everything, it became over complex. So next time I should just stick to the idea I have in my head, which makes it simpler, and go for that one instead. But yeah, I hope you guys enjoyed watching this, and yeah, thank you.